Hello, welcome to chapter 4.6. Today we're going to be doing transformations in a coordinate plane. Now for this, it would help if you have some graph paper to do this lesson. By the end of the day, I hope you can say, I can perform transformations on a coordinate plane and decide whether it's a reflection, translation, rotation, glide reflection, or dilation. Now a dilation, we haven't talked much about yet, but that just makes an object larger or smaller. Now we wanted to review these reflection, translation, rotation, and glide reflection just to get you prepared for what's coming up on the test. So a reflection, um, of course, is just one reflection. And if we talked about the orientation changes between the original and its image. Now the translation is a composition of two reflections, and I hope you also know that it's a composition of two reflections over parallel lines. Now I'm going to take this and copy it and paste it, because rotation is a composition of two reflections, but it's not over parallel lines, it's over intersecting lines. So what I hope you can see, that a translation and rotation are both two reflections, but a rotation is over intersecting lines, where a translation is over parallel lines. Now a glide reflect, oh, and we should talk about orientation. On both these, orientation uh, stays the same. And I'll just copy that and paste it. Oops, that's not what I was looking for, but here we go. Orientation stays the same. Now on a glide reflection, it's a composition of three reflections, or we can say that it is a reflection and a translation, because a translation is two reflections. So, or we can say it's a reflection and translation. Now, in this one, the orientation will change. All right. So that's just a little bit of review. To get into what we're dealing with, transformations, now we take every point x, y, and we're going to move it to this new rule, x plus 3, y plus 3. So first what I want you to do is, on a piece of graph paper, make a coordinate plane where this is your x, and this is your y, and we'll plot these points A, B, and C. So A is at 0, 0, B is at 3, 5, and C is at 6, 2. Now connect those in order to form a triangle. It's best to use a straight edge so it's as straight as possible. Now we're going to take each of these points and we're going to transform them with this rule, x plus 3, y plus 2. So my A prime, my image of A, is going to be my x value plus 3. 0 plus 3 is 3. My y value plus 2. 0 plus 2 is 2. Now my B is going to be transformed to B prime. 3 plus 3 is 6. 5 plus 2 is 7. Now my C is going to transform to C prime, which is 6 plus 3 is 9. 2 plus 2 is 4. So I have my 3 points. I'm going to graph these in blue. So 3, 2, 6, 7. So A prime, B prime, and C prime is 9, 4. Now when I connect them, now let's think about what type of transformation this was from the original to the image. Well, the orientation on the original is clockwise. The orientation on the second one is also clockwise. So we know it can either be a rotation or a translation. This doesn't look like it rotates at all, but it does look like it slides up here. So a translation is going to be what this is. This moves it to the right 3 and up 2. Right 3 and up 2. So each point moved to the right 3 and up 2. Now if I wanted to move down, I would just have to say y minus 2 or y minus whatever value you want to move it down. If I want to move it to the left, I just have to say x minus whatever value, and that would shift it to the left. Now on your own, uh, plot these points, use this rule, and see if you get a translation that's 5 to the right and 2 down. Pause the video and see if you can do that on your own. All right. Now, in general, if it's just a horizontal translation, you're going to add something to the x. If it's just a vertical translation, you're just going to add something to the y. An oblique translation just means it's vertical and horizontal. You're going to add something to the x and add something to the y. Now what you could add is a negative number, which makes that x minus. That would move it to the left. And again, y minus some value would move it down. Now let's graph these 3 points and try this transformation and figure out what transformation occurred. We have 8, 1, 3, 3, and 7, negative 5. All right, now we're going to take each of these points and we're going to translate it, or we're going to transform it, I should say, using this rule. And this is a little difficult for students to wrap their head around at first. We have x and y, and now our transformation will be negative y, so negative 1 in this case, and then the next thing is going to be x, which is 8. So I plot the point negative 1, 8, and that's my a prime. I should have labeled these. This is B, this is A, and this is C. So now if I continue, this would be B prime, will be negative 3, 3. That's my B prime. My C prime is going to be 5, 7. So I'm going to go 5 to the right, 7 up. Now when I connect these, let's take a look and see how this moved. Well, if we look at the orientation, this goes counterclockwise, and so does my image. So it's either a translation or a rotation. Hopefully you can see I'm not just translating this up. So this will be a rotation around the origin. So we can say this transformation is a rotation. Now there's a few different ways we can rotate things. I want you guys to try this one on your own. Pause the video and see if you get a rotation. All right, hopefully you're done with that. And I want to show you the rules for rotations. You can do a 90-degree counterclockwise, and that rule would be negative yx. That is like what we just did here, y negative x. That's 90 degrees. If I want to do 180 degrees, that would be negative x, negative y. 270 degrees counterclockwise would be y, negative x. Also keep in mind if you want to go clockwise, 90 degrees counterclockwise is the same as 270 degrees clockwise. And 270 degrees counterclockwise is the same as 90 degrees clockwise. All right, those are some rules. Now if we want to do some reflections, on the coordinate grid, reflections are done when a coordinate is made negative. For example, Uh, if we have, first let's plot the points 4, 1, 3, 3, 1, negative 1. All right, so I magically put A, B, and C on on the graph. And I hesitated a little bit when I read this, and it's not entirely correct. Um, when reflections are done when a coordinate is made negative, that's just when it reflects over the x-axis or the y-axis. I need to pause to wrap my head around that for a second. Now, if I make this negative x, y, that means my a prime will now be negative 4, 1. So now I go negative 4, 1, that's my a prime. Now 3, negative 3 will go to negative 3, 3, and negative 1, 1 will now go to negative 1, negative 1. So now if we graph this, we'll see that this is a reflection of our pre-image, and it's going to reflect over the y-axis. So if the x is negative, it reflects over the y-axis, and if the y is negative, it's going to reflect over the x-axis. So these are the rules for reflections over axes. However, we can do reflections over many different lines. Here's two examples that are common. A reflection over the y equals x line. That's the graph here with a slope of 1. That just switches your x and your y's. If it's across the line y negative x, that's going to be negative y negative x. Now, if we want to change the size, as in a transformation, or as a dilation, say we wanted to make this 3 times as big, well, we just multiply our x's by 3 and our y's by 3. So our generic rule is you multiply your x value by some number, k, and you multiply that same value by y. Now we could make it smaller by multiplying it by 0.5 or 0.25, or we can make it larger by multiplying by 3 or 7. But those are how we make dilations. All right, hopefully this is good enough to get you through the homework. Good luck.